Let me start. Good morning to everybody. My name is Viswanath, and in Enhanced EDU there is a theme, a running theme called Initiative for Responsible Programming. And I would like to talk to you on behalf of this theme about this theme. Shall I continue? Are you with me? Shall I continue? Okay. You have learned how to use Raptor, strings, arrays, and some other aspects of Raptor. Today I'll talk to you about using subcharts in Raptor. And along with this idea of subcharts, I will explain to you the idea of spaghetti code versus modular code. After some time, I shall tell you what these things mean. So first we shall look at the question of what are subcharts, why should we use subcharts, and how should we use subcharts. We shall do that by showing some examples. You already seen this example of computing compound interest. We shall revisit this example and look at it carefully. And when you write it as standard program, what is lacking in it and how we should make it modular using subcharts. So just to recall the basic notation, we want a program to compute the amount of payable over after n years when the principal amount P, the rate of interest R, and the number of interest years N have been input by the user. The program should check if the inputs P and R are positive and if N is a positive integer. Recall that the formula for A is given by A equal to P times 1 plus R by 100 power N. So if you go to the standard program, right. So you see that even such a simple program, you cannot have it in a single screen.
Please give us a couple of minutes, just a second.
Right. So you can see that even for such a simple program here, the chart is too big for the screen. Let us examine it carefully, see what is happening. We are starting here and then we ask for the principal amount, and once we get the value of P, we check if it is positive or not. If it is not positive, we inform the user that P should be a positive number. If it is positive, we ask for the rate of interest R, and if it is not positive, again we tell the user R should be a positive number, and if it is positive, we ask for the number of years, and in this time we should check if N is not only positive but it should be an integer. Something is an integer if its floor is the same as this value, floor N equal to N. So N greater than 0 and floor N equal to N. If both these conditions are satisfied, we continue with the computation. Otherwise, we tell them put the output N should be a positive integer. And if all the conditions are met, Then we compute the value of the amount returnable and we ask for the output to be displayed. So that is how it runs. You are already aware of that. So now let us look at it a little more carefully. This program doesn't have any modular structure. Whole program comes in a single flowchart. And even such a simple program as this one, the flowchart does not fit fully into the frame. We shall see next how to rewrite this using subcharts. So now you see that there is a main program and you see 4 other tabs, W1, W2, W3, W4 next to that. These are all the subcharts. Main is the main chart. And what we have done now is that the main program is only for getting the inputs. We start, we get the input P, we get the input R, get the input N, and then we call the subchart W1 by this function call. Let us see what W1 is doing. W1 checks for the correctness of P. If P is greater than 0, it goes to the next step. Otherwise, it outputs P should be positive. And what is the next step? That is the chart W2. W2 says, W2 looks at R. If R is positive, it calls W3. Otherwise, it says R should be positive. And what does W3 say? As you can expect, it checks for N. If N is a positive integer, then it calls W4. Otherwise, it says N should be a positive integer. And what does W4 do? W4 computes the value of the amount returnable and outputs A. Now, what is the advantage of doing it this way? The advantage is that the code is more easily maintainable. Suppose the rules change and different number of years have different rates of interest. If we had one big program, then to make the changes in this big program is little messy. But now all we have to do is to change the modules, if necessary add more modules, that is add more subcharts, and it is very easily maintainable. Now I hope you understood the concept of modularity, right? So in the second program, we have one main chart and 4 subcharts. It's easy for us to visualize each subchart separately. They are connected together in this case in a very simple way. Main program calls W1, which calls W2, which calls W3, which calls W4. Sometimes it could be more complicated. Sometimes a program, a subchart can call itself and so on. So as I said, if the rules change, and there are different rates of interest for different numbers of years, it's easy to add some more modules and in that way change the program. So shall we go on to the next program? If you are with me, say yes please. Somebody say yes. Yes, okay. Now this is again a very simple program, finding the array minimum. Okay. So the problem asked us to write a wrapped up program to find the smallest value in an array of numbers input by the user. Once again, let us first look at the program as a single flowchart. Right. So this is the full chart appearing on a single screen. Once again, see, we start asking for the length of the array first, and if the length of the array has to be a positive integer, if not, there is an error message. If there is, we ask for the user to input the values of the array. We already learned how to do that, but let us go over this quickly and carefully. We set the counter to 1 and start looping. Ask for the value of the array. So whatever value you get becomes value of array 1. Suppose n enter the value of the length of the array is 5. Then you have first 1, 1 equal to 5 is not true. So increase 1 to 2, you go back up and get array 2 value. When 2 is not equal to 5, come down again, make it 3, go to the loop, get value of array 3. Then 3 is not equal to 5, come down, make it 4, go up, get array 4. 4 is not equal to 5, come down, make it 5, go up and get array 5. So when you come down here, the value of 5 equal to 5. So all the inputs have been taken. So we go on to the next phase of the program. Next phase introduces two programming variables, I for the counter for the entries of the array and another number m to hold the minimum value. We initialize I to 1 and we initialize m to array 1. And then the loop tells you, now we are doing the assignment after checking. So we check for I get greater than n. And then one by one we set m to minimum of m and array 1, then min of m and array 2, min of m and array 3, min of m and array 4, and then min of m and array 5. And by that time the loop is over. So m has been got to be minimum of all the arrays. So now we display the value of m, we get the value of the answer. Let's check if it works. Let's hope it works. Let us say length of the array is 5 and input let us say 3, then 5, then 1, then 2, then again 5, right, minimum value is 1, right. So the program is running. So once again we see that for a simple problem, the chart doesn't fill the entire space, fills the entire space, it's difficult to get an overall view. Now once again let us separate it main and program in two subcharts. So in this case you see the tabs main, W2 and W1. So here once again it starts and then checks it. But this time the program, main program gets the values from the user, initializes the programming variables m and I and then calls W1. That's all it does. And W1 goes through the values of the array one by one, finds the minimum and then it calls W2. And W2 displays the value of m. So what is advantage here? Now suppose instead of minimum, you are asked to find the maximum. Then we need to change only one module. The second, the module W1, which tells us how to find the max instead of the min. So whenever there is a slight change in the program, you only change one module and it becomes much easier to maintain this program. So now you have seen these two examples. I want to explain to you the concepts of spaghetti code and modular code. This is a typical picture of spaghetti, right? It's all threads, they are all completely wrapped up. You know how difficult it is to remove one string from the mess of strings. If the entire algorithm is written as a single program, then the different threads of reasoning and computation become entangled, just like spaghetti. And it becomes difficult to separate them out for understanding and maintenance. So we don't want spaghetti code. Clients typically say, please don't give us spaghetti code, give us modular code. And what is modular code? Modular codes comes in separate blocks. They connect together. And when you connect it in this way, we can write each one module at a time. Each module can be examined independently. Then they could all be brought together into a single program. This is the difference between spaghetti code and modular code. So in Raptor, the subcharts are, the modules are called subcharts, and each subchart is globally defined variables in the main program. Does a single simple job. In other languages like C and Java, subcharts themselves have their own program variables to be initialized separately, and they are very often they are completely self-contained. And then each subchart has a different name that identifies it, and it may be called by name from either the main program or from any other subchart. It's very convenient. So if you do this in this way, then a program is broken up into modules. It is easy to be written one module at a time, and work can be apportioned among members of programming team, with each team member taking responsibility for one subchart. And real-world large-scale programs are written in this way using modules. So then the question arises, okay, I'm giving you a small reference here, use of functions in programming. This slide will be available to you in the portal, so you can check it later. Now the question arises, how do we write modular programs? We explain one particular method called the work breakdown structure method. This has been explained on the portal earlier. You may not have seen it because we have made it voluntary for you, because there is not enough time to learn the whole thing afresh each time. The basic idea is this. In the portal we have explained several examples. We will only illustrate the method here with two simple examples. Participants are encouraged to study this method in greater detail. Once again, let us look at the compound interest problem. We know actually the problem. So what we want to do is this. We want to give you a very specific method of designing a program. You follow this sequence of steps every time to design a program in this particular way. The first thing to find out in starting the solution is what are the terms and conditions of the program. In this case, we are being told that there are predefined functions in Raptor, min, max and other things, arithmetic functions, and we are being told they can be used. That's good to know. And then we are being told that inputs are three inputs. P has to be a positive number, that is the principal, R is a positive number, that's annual rate of interest, and N is the number of years. And then we start the programming. In the main part, initialization, we say that P, R, N and are user defined. And then we start writing the program. See, we imagine that the program is actually work done by people. So we call the modules workers. And then we call the workers W1, W2, W3. There are three different workers. And how do we plan the program? We plan the program by giving a little piece of work to every worker. We say that first worker will check if P is greater than 0, and if so, he calls W2. Otherwise, the outputs P should be positive. Second worker checks for R. If R is greater than 0, he calls W3. Otherwise, the outputs R should be positive. Third worker checks for N. If it is also a positive integer, he calls W4. Otherwise, the outputs N should be a positive integer. That's how we think of each worker doing the work. Then we can make a table. This table is standard table, right? We make 4 columns giving the worker, the case the worker has to check, action he has to do, and the next call he has to make. Start with start tells you to call W1. Then, so first W1 comes on, he checks if P is greater than 0. If it is, then there is no action to be done, he calls W2. If it is not, the outputs P should be positive and he ends the program. Then, if W2 is called, that means P is positive. W2 checks for R. If it is positive, he has nothing to do but call W3. If it is not, the outputs R should be positive and ends the program. If W3 is called, he checks for N greater than 0 and floor N equal to N. If that is true, he has nothing to do but call W4. If not, W4 checks N should be a positive integer and ends the program. Then W4 computes the amount and outputs the amount. This is a typical chart which we call the WBS table, work breakdown structure table. Every time you write a program, this is how it is written. It is in 4 columns. given the names of the workers, what is action he has, what is the case he has to check, what are the different cases he has to check, and in each case, what is action he has to take, and whom he has to call next. This is a complete program representation. It's completely precise. We can analyze this mathematically, and we can convert it into any language we like, C or Java or Python or whatever. So this is a very convenient way of looking at programs. Just imagine you have been teaching programming using, let us say, C for 3 years, and you have collected a whole lot of examples, maybe 100 examples in C, and then the management says, let's start teaching Python because now MIT is teaching Python. What happens to all your programs written in C? How do you convert all of them to Python? This becomes an issue. But if you maintain all your programs in the work breakdown structure, it's a very easy job to rewrite them in any programming language. And in fact, we can build machines to convert the work breakdown structure into any programming language you like. So this is a very good way of writing programs and a very easy way of developing programs. And we hope to teach you to do these things if all of you are interested. Then let us look at one more program, the array minimum program. Once again, to revise the main ideas, the terms and conditions are that the raptor function min may be used, the inputs are n, and all the array numbers for array of length n, output is again a number. And what is the plan? You just need two workers. For worker 1 successively sets m to min of m and a1, then min of m and a2, min of m and a3, etc. till he reaches the last entry, and then he calls w2, and w2 will give the value. And then for installation and the main program, n is input by user, n is not positive, then the output n should be a positive integer. If it is, then we get the user values, then we set the value m to a1, and then we move on to the next one. We get the table as before. WBS, see, first column gives the worker, second column gives the case he should check, third column gives the action, fourth column gives the call he is to make. So start is the W1. W1 first check for I less than or equal to n. If it is so, then he sets m to m, min of m and ai, then increments I to I plus 1. He calls himself again. Again, if checks if I less than or equal to n, repeats and calls himself till I becomes bigger than n. Then he skips and calls W2. W2 outputs m and ends the program. So what have we learned by this method? We have shown you the difference between spaghetti code and modular code. We have showed you two examples. We explained why modular structure is important. We illustrated the work breakdown structure method for constructing modular programs. You will continue this theme when you learn Java. Before I close, let me say some general things. Now, most of you students are looking for jobs as programmers. And what do employers want? Most importantly, they want employees to accept responsibility for their work. Right? So what does it mean being responsible for a programmer? To what extent can you take responsibility for a program and guarantee your program? What does responsible programming mean? It means you should be able to answer the following questions affirmatively. Does your code work? Does it always give correct answers? Is your code efficient? Is it reliable? Is it maintainable? Is it modular? Is it robust? These and such questions are what are necessary at the industrial level programming. We should learn as students how to do all these things, even for simple programs. If there is enough interest, we can discuss these issues further. You can always contact us at this email address. So thank you. Now my presentation is over. If you have any questions, let me know. We are still in the chat mode. Okay then, if you think of any questions later, you can either call us or inform us in some other way. Now I'll give you a break for 5 minutes. Don't go away. It will be continued in 5 minutes. Thank you. Right. See, idea is to explain the concept of modularity. So I did not take up a new example. What do you mean some faculty may not follow? Predefined, what should I do otherwise? I have taken standard examples. Tell me please, what is it you're not able to follow? I explained two examples with implementation, right, in work breakdown structure. In subcharts, I told you two subcharts now, two programs with subcharts. Please talk, I can hear you. You want me to go through the examples again? Shall I go through the examples again? Okay, okay, all right. Right. First of all, we check the standard way of writing programs in computer science, in the compound interest problem. You notice that whole program takes up too much space and everything is put together in one single chart. And then you observe that if the rules change, and and they say that for different numbers of years, the rates of interest are different. Please change the program for us. It will be difficult to change the program in the full program as it is. So that it will be more convenient if we write it in a modular style. So in this case, there is a main program and there are 4 subcharts. Main program, this is main program, right? Okay. So the main program only gets the values of P, R and N. That's all it does. The convenience is that it fits in a single frame and you see what it does. Then the second program, that is second subchart W1, checks for P. If P is greater than 0, P should be positive, and then if P is greater than 0, if not greater than 0, it puts P should be positive. If it is, it calls W2, and then W2 checks for R, and W3 checks for N, and just suppose here that the rate of interest depends on the number of years. Then what we would do is to make W4 W3 and make a check whether the number of years satisfies the conditions given by the bank, and depending on the conditions it will go and check the rates, and then it will continue with the final computation. So it is very easy to maintain the program and make simple changes if they are necessary, if you maintain the program in these modules. So we keep one program to get the inputs and one program at the end to output, and in between to make the computations and check if the necessary conditions are satisfied. Now I don't think we need to go through that array problem also in a similar way. I'll just go and explain this spaghetti code and modular code. That all. Should I explain this again? Please let me know. Okay. Now this is a typical picture of spaghetti, and we all know when it is eating how when you lift the fork all of the things get entangled and it's very difficult to separate them out. This is an example of a bad program. Think of every thread as a thread of computation or a thread of reasoning. If you put everything in a single big program, all these different threads of reasoning and computation become completely entangled. It becomes difficult to separate them out for understanding first of all, and then for maintenance. As I said, in the case of maintenance, some rules change, the program needs to be changed in certain ways, and then where do we go and change it in this mess? It's not at all clear. So spaghetti code is a bad code, bad way of writing code. Whereas modular code is in separate modules. In the case of Raptor, it is in terms of separate charts. In the case of Java, it will be different classes and methods and objects. And each module has its own existence. It can be checked separately, and they all fit together in one particular way to create the entire program. It gives a beautiful structure. Each module can be written separately, checked separately, independently. Then you bring them all together into a single program. This we have repeated earlier. We have seen the advantages. Real-world programming is done in terms of modules. Then the next question is, how do you write modular programs? What is a pedagogic device which will help us write modular programs? So we have worked on a method which we call the work breakdown structure method. This depends on the idea that for all of us, it is easy to do a piece of work if we think of it as being done by people. If I have to organize a birthday party and I am told that you will have enough helpers to organize the birthday party, it's very easy for me, not only for me, for everybody. So, okay, each person has to do this work and this work. You have to check with each other in this particular way. Then at the end, we know how to run the birthday party. So think of a program as a party. There are several workers given to you, and you are told what capacity each worker has, and what you have to do is to tell each worker what the worker has to do to run the entire program. So let us look at this component test program again. This is the problem we have seen, and we have worked out a specific template. We can work along with this to help you write the program. First thing is that a computation problem depends not only on what is to be computed, but what are the resources and what are the constraints on resources you have to compute. So first thing is for you to find out what are the terms and conditions for programming. What are the library functions available? What are the checks you can make? Can you check for A equal to B, or you can only check for A minus B equal to 0? Such are things you need to know when you write the program. Once you get the terms and conditions clear, then you ask for, okay, what are the inputs? In this case, the inputs are P, R and N. And then the program starts. Main program usually gets all the user inputs, and if there are any other programming variables, it tells you how to initialize them. So getting user inputs and initializing the new programming variables is the job of the main programmer. So P is user defined, R is user defined, N is user defined. Think of the main programmer as manager of the team. He does all these jobs, and then he starts assigning work to the workers. And he plans the work in this way. He says, I'll have first worker. His job is to check for P. If P is greater than 0, he simply calls W2. Otherwise, he outputs they should be positive. Then I have one more worker, W2. He checks for R. If R is greater than 0, he calls W3. Otherwise, he outputs R should be positive. When W3 gets his chance, he checks for N. N is a positive integer, he calls W4. Otherwise, he outputs N should be positive integer. And W4 simply computes A and outputs A and ends the program. This is how I plan the program in my mind before I start writing it. Once this plan is clear, I have a very specific method of writing this. I make a particular table. First column has all the workers. Second column tells me what are all the cases a worker has to check. For every worker there are some cases, case 1, case 2, case 3, case 4. He checks if case 1 is satisfied. If so, he takes action 1, he calls the next worker. If case 2 is satisfied, he takes action 2 and he calls another worker probably. If case 3 is satisfied, he takes action 3 and it could be another worker, perhaps himself. Similarly, for every case there is some action to be done and the next worker is called. So in this case, worker 1 checks if P is greater than 0. If it is, he has nothing to do, he simply calls W2. Otherwise, he outputs P should be positive. When W2 gets his chance, he checks for R to be positive. If it is, he has nothing to do, he calls W3. Otherwise, he outputs R should be positive. When W3 gets his chance, he checks if N is greater than 0 and N is an integer, and he has nothing to do, he calls W4. Otherwise, he outputs N should be a positive integer. And W4 computes A, he outputs A and ends the program. This is a very, very definite way of writing the work breakdown structure. It is completely mathematical. We can analyze it for termination and correctness. You can learn it if you come for advanced courses. And this is something which is completely precise. We can create machines, convert this structure to either Java or Python or C or whichever program you want. And independently of any programming language, independently of syntax problems, this method tells us simply and logically to any layman what is the structure of the program, what is the logical structure of the program. At this level we can understand easily and we can see if it works or not, so that responsible program becomes easier. Similarly, we have other programs, and then I said that summary is that we have shown you the difference between spaghetti code and modular code. We have shown you 2 examples. We have showed you why modular structure is important. Let's read more breakdown structure with 2 programs, and this thing will be continued when you learn Java. You can learn that. There you can explain the W1, W3 in terms of classes, objects and methods. You'll see how easy it is. And then we looked at what employers want. Most importantly, employers want employees to accept responsibility for their work. And if your students want to take jobs as programmers, you should ask yourself, what does it mean to be a responsible programmer? To what extent can I guarantee my program? What are the guarantees the programmers want? Does it work? Most important, functional thing. Does it always give correct answers? Is it bug free? Is your code efficient? Is it reliable? Is it maintainable? Is it modular? Is it robust? These are the questions which need to be asked. You know, in the standards book for software, there are some dozens of standards which program has to meet, which software has to meet. And there are many questions like this. And as programmers, you need to understand what these things mean. Before we start constructing software, we should understand at the level of programs how to create programs that work, how to create programs that satisfy all these properties and maybe some more properties. All this we can take up in advanced course if you are interested. Now please tell me if at least now you understand. Hope I have made myself clear now. Yes, there are lots of